Alright, let us continue our topic in integral calculus using U-substitution. Pero in this video, bibigyan nating emphasis yung integration of trigonometric functions applying U-substitution. First, introduce ko muna sa inyo yung mga trigonometric formulas ang dapat nating tatandaan o i-familiarize while integrating trigonometric functions. First, meron tayong integral of cosine u du is sin u plus c. Next, the integral of sin u du is negative cosine u plus c. The integral of secant squared u du is tangent u plus c. Cosecant squared u du is negative cot u plus c. Tan u du is ln of secant u plus c. The integral of cot u du is ln of sin u plus c. The integral of sec u tan u du is secant u plus c. And the integral of cosecant u cot u du is negative cosecant u plus c. So, sila yung dapat nating tatandaan while integrating trigonometric functions. Mag-example na agad tayo. So, for our first example, let us integrate cosine 7x plus 5 dx. Since gagamit tayo ng U-substitution sa pag-integrate ng trigonometric function na ito, again, mag-a-assign tayo ng variable to represent or to rewrite our function. So let u is equals to 7x plus 5. The derivative of u or our du is, the derivative of this is 7 dx. Or our dx is equals to 1 over 7 du. Then, i-replace natin ulit yung nilet nating variable sa ating original na function. So, the integral of cos, ano yung 7x plus 5? Yung 7x plus 5 is our u. Therefore, cos u. Next, yung dx. Ano yung dx? Yung dx natin is ito. Therefore, times 1 over 7 du. Applying natin yung mga previous, so i-apply natin yung mga previous property natin. Constant, pwede nating mapalabas. Magiging 1 over 7 integral of cos u du. Notice that this integral is the same as this one. Therefore, pwede nating sabihin na the integral of cos u du is sin u plus c. Pero, meron tayong value ng u, which is yung nilet natin nung una. Therefore, 1 over 7 sin, ano yung u nga? 7x plus 5. 7x plus 5 plus c. Ito na yung sagot sa example natin. So, let's have our second example. Integrate the function x squared times sine quantity x cubed dx. Pwede natin itong ma-rewrite into integral of sine x cubed times x squared dx. Ni-rearrange lang natin yung example. Next, since this is U-substitution, again, let us let a value for u, let's say x cubed. Then, let's derive our u or du, magiging 3x squared dx. Again, after natin mag-let ng value for u at dinerive yung u na du, babalik ulit tayo sa ating original function. So, rewriting magiging sin, ano nga ulit yung x cube? Yung x cube is yung u, sin u. Notice na yung remaining term natin sa ating function ay x squared dx. Pero anong pwede nating i-rewrite na replacement sa x squared dx? Notice na yung derivative of u is 3x squared dx. Pero kailangan natin na dapat x squared dx lang yung papalitan natin. So, simplifying or evaluating this one, magiging 1/3 du is equals to x squared dx. Meron na tayong pwedeng ipalit sa ating x squared dx, which is yung 1/3 du. 1/3 du. Okay, applyin ulit yung ating power rule or yung mga basic integration rule natin. Pag may constant, pwede natin ipalabas. 1/3 integral of sin u du. Notice that our trigonometric function here is the same as this one. Therefore, pwede nating sabihin na 1/3 integral of sin u du is negative cos u plus c. Evaluating magiging 1/3 negative 1/3 cos u plus c. Replacing the value for u, we have negative 1/3 cos x cube plus c. Ito na yung final answer sa example natin. Let's have our next example. Integrate the function for secant squared quantity 2x plus 5 dx. Again, pwede nating mapalabas yung constant na 4. Magiging 4 integral of sec squared 2x plus 5 dx. Applying U-substitution method, let's say 2x plus 5, and the derivative of our u is 2 dx. Replacing yung nilet natin na value, magiging sec squared, ano nga yung 2x plus 5 is our u, then our dx, so 2 dx yung remaining dito. So, pwede natin itong i-evaluate, magiging 1/2 du is equals to our dx. Therefore, yung value ng dx natin ay 1/2 du. Palabas natin yung 1/2, magiging 4 times 1/2 integral of sec squared u du. Notice that sec squared u du is the same as this one. Therefore, the integral of sec squared u du is, simplifying this one, magiging 2 tan u plus c, and replacing our value for u, magiging 2 tangent of ano yung u? 2x plus 5 plus c. Ito na yung final answer sa example natin. Let's have our next example. Integrate the function cos secant squared quantity x over 2 dx. Since we're going to use u substitution, let u is equals to, let's say this one, x over 2, And our du is 1/2 dx. The derivative of our du is 1/2 dx. Next, replacing again or rewriting our original function, cosecant squared. Again, yung x over 2 is our u. Then, what is the value for our dx? Notice that du is equals to 1/2 dx. Evaluating this one, magiging 2 du is equals dx. Our value for dx is 2 du. Therefore, dx is 2 du. Labasin natin to, magiging 2 integral of cosecant squared u du. Again, notice that our function is the same as this one. Therefore, the integral of cosecant squared u du is negative cot u plus c. Evaluating, magiging negative 2 cot u plus c, and replacing again the value for our u, which is u is equals to x over 2, magiging 2 cotangent x over 2 plus c. Let's solve for another example. Integrate the function tangent 2x dx. So, let u is equals to 2x. Our du, or derivative of u, is 2 dx. Rewriting our original equation, magiging tan, yung 2x natin is our u, tan u, yung dx natin is, notice that du is equals to 2 dx. Evaluating this one, magiging 1/2 du is equals to dx. Therefore, our dx is equals to 1/2 du. Papalabisin natin yung constant, magiging 1/2 integral of tan u du. Notice that integral of tan u du is ln of sec u plus c. Therefore, 1/2 magiging ln of sec u plus c. Replacing the value for u, magiging 1/2 ln sec, ano nga yung u, is 2x plus c. Ito na yung final answer natin. Let's have our next example. Integrate x cotangent x squared dx. So, again, our u, let's say, x squared. Derivative of u, magiging 2x dx. Substituting to the original function, magiging x cot, ano yung x squared? Yung x squared is our u dx. That meron tayong remaining na term na x dx. At yung du natin is equals to 2x dx. We can further evaluate this one at magiging 1/2 du is equals to x dx. Ibig sabihin, yung x dx natin, pwede nating i-represent ng single term na 1/2 du. Rewriting this one, magiging cot u times yung value for x dx is, yung x dx is 1/2 du. palabasin ng constant, magiging integral of cot u du. Again, notice that the integral of cot u du is ln of sin u plus c. Therefore, magiging ln of sin u plus c, the integral of cot u du. Again, substituting, magiging 1/2 ln of sin, ano yung value for u is x squared plus c. Ito na yung final answer. Let us proceed to our next example. Let's say, integrate sec x tan x dx. Or, pwede nating sabihin that as prove that the integral of sec u tan u du is sec u plus c. Ipo-prove natin na yung integral ng function or trigonometric function ito is sec u plus c. Pwede nating sabihin na yung sec x is 1 over cosine x. Diba yung mga trigonometric identities natin? Your secant is equals to 1 over cosine times yung identity ng tangent x, pwede nating sabihin na sin x over cosine x dx. Evaluating this term or expression, magiging sin x over cosine x times cosine x, magiging cos squared x dx. Now, na further evaluate or simplify na natin yung expression, let us let u is equals to cosine x. Derivative of our u is negative sin x dx. Again, sa differential calculus natin, yung derivative ng cosine x is negative sin x dx. Or, we can say that negative du is equals to sin x dx. Notice that sa ating original or sa ating in-evaluate na expression, meron tayo sin x dx, which is ito. Ibig sabihin, yung sin x dx, pwede nating represent ng negative du. Dahil yung sin x dx natin ay equals to negative du. Then, cos squared x, meron tayong u na cos x. So, rewriting our equation, magiging negative du all over cos, or since nilet natin na cosine squared equals u, magiging u squared. Bakit naging u squared? Kasi yung cosine squared x is just the same as cosine x squared. So, ibig sabihin, pwede nating i-replace itong cosine na u, magiging u squared. Kaya, naging u squared yung ni-replace natin dito sa ating function. So, evaluating this one, magiging negative integral of du over u squared. Power rule, applyan natin yung power rule, magiging u negative 2 du. Recalling our power rule, di ba yung integral of a function raised to a certain exponent is that function raised to n plus 1 over n plus 1. So, pwede natin i-apply yung property na ito sa ating integral. Therefore, magiging negative u, ano yung n? Negative 2. Negative 2 plus 1 all over negative 2 plus 1. Evaluating this one, magiging negative u raised to negative 1 all over negative 2 plus 1 is also negative 1. Evaluating, magiging negative times negative, magiging positive u negative 1 all over 1, or let's just say u negative 1. Replacing, magiging, okay, let's rewrite muna. U negative 1. Ano nga yung u? Yung u natin is cosine x. Magiging cosine x raised to negative 1. Or in fraction form, magiging 1 over cosine x. May plus c muna tayo dito Huwag nating kalimutan plus c. Plus c. So, 1 over cosine x plus c, our identity for 1 over cosine plus x is also the same as secant x plus c. Na-prove natin na yung integral ng function na sec u tan u du is equals to sec u plus c. Let's have our last example. Let's say, let us prove that the integral of cosecant x, cotangent x, dx is also equals to negative cosecant x plus c. Or let's prove this property na yung integral of cosecant u cot u du is negative cosecant u plus c through this example. So, rewriting, we can say that cosecant x is also equals to 1 over sine x. Or for cot x, it's just the same, or let us say na yung cotangent x is just the same as cosine x over sine x and dx. So, evaluating this expression, magiging cosine x over sine x times sine x is sine squared x dx, or pwede natin isulat na cosine x all over sine x squared dx. Magkapareho lang yung expression na yan. Next, let us assign value for u. Let's say sine x. Then our du is derivative of sine x is cosine x dx. Notice that in our evaluated expression, meron tayong cosine x dx. Therefore, pwede nating palitan ng du dahil yung cosine x dx is our du. And our sine x is our u. So, rewriting, magiging integral of du all over u squared. So, applying power rule, magiging u negative 2 du. Recall that the integral of a function raised to a certain degree is equals to that function raised to n plus 1 all over n plus 1. So, pwede nating ma-apply yung property na ito in evaluating this integral. So, magiging u, yung n natin is negative 2 plus 1 all over negative 2 plus 1. Evaluating this one, magiging u, negative 2 plus 1 is negative 1. Also, negative 2 plus 1 is negative 1. Evaluating, magiging negative u, negative 1 or in fraction form, magiging negative 1 all over u. Then, substitute back the value for our u. Then, negative 1 over u. Let's don't forget the plus c. So, negative 1 over ano ang u natin? U natin is our sin x. Pwede natin sabihin 1 over sin x plus c. Recalling our identity, trigonometric identity for 1 over sin x is also equals to cosecant x negative plus c. Therefore, na-prove natin na yung integral of cosecant u cot u plus du times du is equals to negative cosecant u plus c using this example. Alright, so in integrating trigonometric functions using U-substitution, ang kailangan mo lang is dapat ma-familiarize mo yung mga formula or properties of trigonometric functions na ito. At yung mga previous basic integration rules natin. So that basic na lang sa inyo or mas madali sa inyong mag-integrate ng mga trigonometric functions, especially using U-substitution. So I hope may natutunan kayo sa video na ito. Please don't forget to subscribe in my channel for daily dose of math, engineering, and coffee.